All right, so I sent you this folder, 113017.zip. I'm going to save it to the desktop. Way too much stuff on my desktop, but that's fine. Then on my desktop here, I'm going to extract it, although I may already have it there, so let me get rid of this. So the folder that I have should be exactly the same as the one you have right now, because I've done the same thing. I decided I'm not going to spend a lot of time talking about a game, because I want to show it to you. So this is that game. I think I showed it to you before. It's the Say Yes to the Dress game. You know, it's got this, and Taylor has got to come through here and try to maneuver her way around. Well, I didn't. And to get to the dress. All right. So, these were the images for the game. So there was, these were the evil wedding dresses that were attempting to come down. All right, this was the background, which was just a bunch of bricks, or a brick-looking background. This was her. She's called the hero. And this was the goal. This is trying to get her to, get to the dress. And you can see the sizes, etc. But I want to just quickly go over the file. There's going to be a lot of stuff in here you won't understand. All right, that's to be expected. I tried to figure out the best way to do this. And then yesterday, I think I've told you I get a bunch of classes through udemy.com. I probably have spent upwards of $1,000 of my own money with them. I'm not asking for pats on the back or anything. I do it for my own knowledge, okay? And yesterday there was a class that was $200 that was on sale for $10. So even though I promised my wife when she got our last MasterCard bill I wouldn't get any more, I got another one. So let's put it this way, come the middle of next month, she'll be pissed at me, all right? But that's life. So in that particular set of videos that I got, they teach you how to create blackjack using JavaScript. I really like the way this guy has done it. So what I've started to do is I started watching his lessons. There's 46 of them, all right? I went through the first about 12 yesterday, and I hope to go through the rest of them between now and next week. And there's a bunch of stuff in there I want to show you. I think that'll help. It'll also fill in some of the gaps for some of the chapters we're not going over. All right. But if you look in here, hopefully by now you've at least seen that particular tag before. It may not have looked exactly like that. All right. But the idea is you should be able to run this program either on a laptop or a desktop or a tablet or even a phone. All right. And that's what the viewport thing is saying. And it's saying basically set up so that its device width works based on the type of medium you're using. And the user scalable equals no means you can't pinch on a phone and make it bigger. Does all that make sense? All right. This is something that's discussed in a later chapter. The canvas is something that's pretty much new in HTML5, but it allows you to draw on your screen. And the way that you used to have to draw on the screen, for lack of better words, was very unprofessional. The way you did it, it looked real herky-jerky. It looked very amateurish. All right. So one of the things they decided to do with HTML5 is to try to provide a better user experience, also known as UX, but a better user experience for being able to draw on the screen. What they came up with was the use of the canvas. All right. Is it the best way? It's the way they came up with. Is it the way I would have done it? Doesn't matter, because the people who did it know a hell of a lot more about this than I do. All right. But what we're saying is that this canvas that we're going to use, we want it to have a 1 pixel border around it that's black, and we want it to take up the entire screen. Now, looking at that, that should make sense to you. All right. But the canvas is actually a control for, like we have buttons and we have text boxes, etc. The canvas is a control. All right. And then we're saying that basically in the body, this is where we set up the canvas. This is where we are using the CSS on the canvas. I put everything together. The JavaScript's in here. It's all in one file. Could have broken it up into 3 files. I didn't do that. All right. But this is the canvas itself, and what we're saying is we want it to take up 640 by 360. Now, it may look funky if you try running it on a phone because it's trying to use those dimensions. It may look funky if you run it on a tablet because it's trying to use those dimensions. You could go in there and do some fudging around and actually make it so it looked nice on anything. All right. So, these are a couple constants that are used. By now, this should make sense to everybody in that the variable game live is a Boolean variable. In other words, it's going to be true or it's going to be false. And like I said, by now, that should make sense to each and every one of you. All right? Now, what you've never seen before is this. These are JavaScript objects. All right? An object, for lack of better words, is a data type we make up. It can have anything in it we want it to have. Now, you're used to seeing stuff like this. Let me show you this quickly. You've seen stuff like this. Var, grades, equal. You've done that, right? That would be an empty array called grades. All right? But if I wanted to create a person, I could say var person equals, and when I do this, that's not an array, that's an object. And an object has anything we want it to have. For lack of better words, just because I want you to hear this stuff, an object has what are called properties. Wow, great pen. It has properties and it has methods. We've talked a little bit about these, but not in much depth. So why am I even wasting your time talking to you about this? Because if you look in here, these are all properties. So every dress object will have an X coordinate, a Y coordinate, a speed that it's going down the screen, a width, and a height. Does that make sense? All right, this is every one of the dresses. And I think there are 4 of them, but I don't even remember. All right, but there's a dress. And they all look the same, except they all start at a different place. See that? Other than that, they're all the same. Those are the 4 dresses, so that on the screen, what we're building there is there's a dress here, there's a dress there, there's a dress there, and there's a dress there. All right? And that's where they are, and the speed on them is 5, 3, 2, and 1. 5 means it's going to come down 5 times faster than 1 with a thing of 1. Does that make sense? But what we're doing here is we're creating our own types of variables. Why would we do that? Because sometimes, we don't have that many variables available to us in JavaScript. And sometimes an int or a float, a number or a null or a Boolean or a string is not enough. So we create our own. So that's what we're doing right here. So we have 4, we are creating an array called dresses, and that array, which starts here and ends there, has 4 different objects in it. There's the dress 1 object, there's the dress 2 object, there's the dress 3 object, and there's the dress 4 object. So in the past, when we've created arrays, we always made an array of ints, or an array of strings, or an array of Booleans, or something like that. Now we're making an array of objects. All right? Then we also have another object here. Notice there's only one of them, so it's not in an array. So a Taylor object, again, has an X coordinate, a Y coordinate, but remember, the dresses are falling down, correctly? Correct? You saw that, right? That's moving down the y-axis. Taylor is moving across. So where the dresses have a y speed, Taylor has an x speed. Does that make sense? All right. Then there's an is moving. and it's going to be set basically either to 0 or 1. If it's set to 0, she's not moving. If it's set to 1, she is moving. Okay? And she's got a width and a height. I try to make them all pretty much the same size. 40, 40, 40, 40, etc. All right? Then finally, we've got that Randy object. It is a little bit different size because I couldn't scale that picture very well. All right? But this is the thing that's at the end. That's the prize. That's the picture of her and that Randy guy. Notice he doesn't have any speed because he's not moving. He just has a location and he has a height and a width. Now, I'm not saying to you, does that make sense? But all we're doing there is we're laying out everything on the screen. So when we get done, we've got this. We've got the first dress, we've got the second dress, we've got the third dress, we've got the fourth dress. We've got Taylor over here, and we've got Randy over here, which is Taylor and Randy. Does that make sense? And the dresses are falling like this. This is falling at speed 1. This is falling at speed 2, at speed 3, and at speed 5. So like at 100%, 200, 300, and 500%. All right? Taylor is moving this way. She moves at a constant speed, and she moves based on you moving the mouse. These things move automatically because we tell them to. All right? So that's, like I said, that, for lack of better words, that's the game board. All right? So, next. We've got an an object called sprites. And what is that? Well, those are the images. We have to let the system know where on the screen we want to put the images. And what images, we're telling it there pretty much where we want things to go, but here we're equating them with the actual names of the files. All right? So before we were laying out the board, now we're putting those images where we want them to go, for lack of better words. All right. Then we've got a bunch of stuff in here. Notice it says move player. Taylor is moving is true. Stop player. Taylor is moving is false. I'm asking you this question. Do both those make sense? The first one says, I want her to move. And what this is we're going to take this and we're going to align that with you pushing down on the mouse and moving the mouse. And we're going to equate that one with you letting go of the mouse. Does that make sense? All right. Now, when you use a canvas, this is a pain in the butt, but when you use a canvas, you have to do what's called create a context for the canvas. Why do you have to do that? Because not only can you make 2D, you can make 3D canvases. You know, with 2D, hopefully you all know this, but with 2D, which most of us are used to working with, you've got an x-axis and you've got a y-axis. I did it backwards because that's x and that's y. Does that make sense? But when you work with 3D, you also have another axis here that's referred to as z, and it's an axis that gives you depth. We don't have any depth in this game. I read this thing, and I thought it was actually a pretty good analogy to this. That you've all seen this before, right? You know, you go and you look, and we've got this. And this says, you know, cream of mushroom. So it's Campbell's soup. All right? So what is that? Well, you take the label off, and the label is just flat. Would you agree with that? If you took the label off of a can of soup, it's going to look pretty much like this. It's just going to be flat. But once we take it, we put it on a can of soup, it has depth. It actually looks like it's circular in nature, even though it isn't. That's kind of what we're talking about here. All right? But our game is just simple. It's 2D. So we set up a 2D context. This should look familiar to you. We want to be able to use, we called it My Canvas in here someplace, way up on top. ID equal My Canvas. All right? So when we want to be able to manipulate the canvas, all right, we're using the document.get element by ID. You've seen that already. All right. Then we have to set up all these listeners. Now, This is what I want you to get out of this. Please look up on the screen. Because we've done event listeners, but I probably haven't done a very good job of explaining them. What this is saying is, when I click down on the mouse, we want you to equate that with the move player function. When I let go of the mouse, I want you to equate that with the stop player function. In English, what that means is, when I click down on the mouse, make Taylor move across the screen. When I let go, have her stop. All right? And we also have touch start and touch end. These do the same thing, but they would do them on a phone, because on your phone, you don't have a mouse to use up and down. So instead of a mouse down, you use a touch start. Instead of a mouse up, you use a touch end. Does all that make sense? So I tried to set this up so that you could use it either for, like I said, for a computer or for a phone. All right? Now, the hardest part of this function is this. Because you have to find a way that you have to check, okay, there was a collision. So what kind of a collision was there? And in other words, if I made it all the way to the end, so in other words, if Taylor collided with Randy, I made it all the way to the end. So, say yes to the dress. We won. Okay? And then we reset the game, which means I can play another one. So immediately reset the game for us. But if that wasn't the case, and that's going to be down here, I have to check for a collision. And if I didn't collide with Randy, I collided with a dress. So the game's over. Does that make sense? All right. This basically says, okay, if I'm moving, I have to update the status. Remember, Taylor's moving across the x-axis. So every time I click down, she's moving from left to right. So I'm updating her status right there. But I also have to update basically the status of the dresses, because they're falling down. Why do I have to update the status of the dresses? I want to make sure when they reach the bottom, okay, they come back up again. It wouldn't be a very hard game if they reached the bottom and they just kept going. Does that make sense? Because then eventually they'd be off the screen and I could just win every time. That'd be stupid. All right, so the idea is those dresses come down to a certain point near the bottom, boom, and they go back up again. They reach a certain point from the top, boom, they go back down again. That's what we're telling it to do in here. All right? We're telling it to check its borders. And if it falls within a certain range, okay, we want it to either go from down to up or from up to down. Does that make sense? This, as it says, shows the game on the screen, so it's drawing everything out. This is the thing that keeps running. So in other words, this step, this is going to be called every millisecond, because it constantly has to update where Taylor is on the screen, where the dresses are on the screen. Are we still playing? If not, did we lose? If not, did we win? And that's what it's doing in there. This thing in here literally has got some math in it, and it's doing the collision. So it's got to go and it's got to use some mathematical coordinates to figure out, okay, what did I collide with, for lack of better words. Now, that was actually longer than I planned on even spending on it. But what I want to tell you is this. In the handout, so in the handout that I gave you, get rid of this. So in this handout that I gave you, there is also in here, have you all seen Breakout? All right. Well, I grabbed that. I didn't do this. I grabbed that from here. All right. So I grabbed that from developer.mozilla.org, which has out online 2D Breakout game using pure JavaScript. It's a 10-part series. I don't know if I can back up one or not. Nope. Let's see. Well, it's like I said, it's a 10-part series that you can run through, and what I've done is I grabbed all 10 parts, put them in here, and gave you the final HTML and the final JavaScript. when you run this, there it is. It doesn't run fast. And not only that, guess what? You can't lose. So you could say well, that's not a very fun game, because it should happen that when it gets down to here and you haven't hit the thing, all right, I guess it gives you 2 or 3 times. I guess you can lose, all right? But notice I can keep playing, and as long as I'm knocking things down and it hasn't reached the bottom, okay, as long as I've got a life left, so there I won. Does that make sense? And when you look at this, like I said, it's a 10-part series, and part 7 in here, if you're interested, is all on collision detection. So if you wanted to actually learn the mathematical involved in it, all right? I always find this is me because I've got a weird sense of humor, but I always find this personally to be funny. I'll always remember I had this guy named Jason who came into my class when I was at Blackhawk many, many, many years ago, dressed entirely in black, all right? Black trench coat on, black, can't even think of it, black shirt on, black pants on, black army boots on. I'm not making this up. The right-hand side of his hair was down to his shoulders. The left-hand side of his hair was completely shaved. All right, I'm thinking, okay, this is going to be interesting. And the first words out of his mouth are, when are we making games? Just when he walks in the door. And I said, we really don't do much games, but you will get the knowledge. And he actually ended up becoming a really good student. All right, and he was very normal. He didn't look very normal, but he was very normal. But what I did was I found an article like this, and I pointed him in that direction. And as soon as we learned our first language, which was JavaScript, he started making simple games. All right? Most of the ones he made were pretty simple, but they were pretty good. Now, you may or may not have heard of this, but there's a package out there that's called Unity. Again, you may or may not have heard of that. What Unity does at its very core is it's one of the biggest softwares that are out there right now for games. All right? And it uses C# at its base. I'm starting to teach myself Unity right now, okay? If we can go through the C# stuff at the speed I hope we can go through it next semester, we may have a week or 2 at the end of the semester. If we do, I'm going to teach that to you. Now, if you want to load it, you can. It's a pig. What do I mean? It's about 500 gig. It's not small, so if you don't have much room on your machine, you're not going to be able to do a darn thing. But I had room on here. I cleared a bunch of stuff out. Maybe it's not that big. Maybe it's more like, I don't think it's 500 meg, but it's at least several gig. All right? Okay. So if you are interested in that, like I said, you've got that in there also. So I showed you that game. I showed you that game. What I want you to do is, if you have it with you, is I want you to open this up. This array 01. There's an array 01 and there's an array 02. All right, we're going to look at the array 01 right now. All right, if you run it, doesn't look like much, and it comes up with this. And here's, should not be a big surprise to you, other than option 0, which says exit, none of these work. We're going to go through how to make all of these work right now. You've got the JavaScript file. I kept the comments in there. Hopefully that when you took the test yesterday, you found having those comments in there helped as you were writing the code. All right. I will tell you right now, here's a big hint. When you take your last test, which will be whenever it is, next week, week after, probably the week after that, I guess, you're going to redo this. You're going to redo the BMI thing one last time, but instead of just pure JavaScript like you use this time, you're going to use jQuery. All right, and you will do a little bit, if I can figure out how to implement that, of like try-catch. That'll be part of the test. That's the stuff from chapter 12. We haven't gone through that yet. The other part that we're going to go through, the array stuff, I don't know how I can implement that in here. So you might have to create another program. There may be 2 programs for your last test. All right? And that one will have some array stuff in it. I'm not sure yet. I haven't created it, so I can't tell you. All right. So right now, like I said, if I choose 0, boom. it quits the program. All right? But if I choose anything but 0, for example, I'll choose 7, and I put a 7 in here, it doesn't work because the code isn't in there yet. That should make sense to all of you. So what I'd like you to do, please, is to bring up in Notepad or whatever editor you happen to use this index.html file, all right, which is very small. That's it. We're not going to change that, but that's the one we're going to run to make the program go. And then under JS, I want you to bring up it's called array fun. And that's what we're going to look at right now. All right, we'll look at this for and start working on this. We'll take a break at about 5 to 9 till 5 after 9. I'm going to start up right then, and I'm going to go till a couple minutes before 10. And like I told you before, then I have to call Evan and Paul at the St. Louis campus, and hopefully we have 4 courses we have to agree on for books. One of them I think is already done. I think it's done. Another one is the same book that you guys will use next semester, but it's upgraded for Visual Studio 2017. If they want to use that one, then 2 of the 4 classes are already done. So we have to go through and do the other 2 classes. If it takes 5 minutes long each, boom, I'll be back here at 10 after. If it takes 15 minutes long each, boom, I'll be back there at 10:30. That make sense? All right. So, all right, this is me speaking. This is a relatively simple JavaScript program. Now, relative is a relative term. If I say, relatively speaking, quantum physics is easy. You might think, yeah, I suppose if you have a physics degree, all right. So what I'm saying is as we go through this, I decided to do it like this, whether he realizes it or not. Colin's already written this program, but you wrote it in C#. All right. And we're going to go back and redo it in C# next semester so you can start to see the differences between doing this in C# and doing it in JavaScript. Not only that, when we do this next semester, you're going to learn how to make C# programs in 2 different ways. All right? Now, some of you may be very literal people. And what I mean by that is give you this, and you're happy as hell. So you've got a command line interface. So the first thing you're going to learn is how to create C# programs from a command line interface. Okay? Then we're going to create C# programs, the same programs, but instead of using a command line interface, we're going to make them GUI. Now, I recommend that after we do that, that you do everything GUI. We had students last semester that loved doing things from the command line. They didn't want to worry about working with graphical user interface elements. All right? So when we take our first test or 2, for the first 2 tests, I'll probably have 2 problems. You'll do one as a console app, like I just showed you, and one as a GUI app for the first couple programs. Then when we get to the 3rd test, I'll say, now you got your choice. You can use either one. I don't like that because then I have to write 2 keys, and I'm lazy. So I don't really want to do that if I don't have to. But I'll do that if you decide that you'd rather do it. I'll do it graphical every time. All right. So this presents the menu. You already saw the menu. These are the 9 possibilities. If you type in a 0, the program ends. Okay? If you type in a 1, it's going to randomly generate 25 numbers between 1 and 100. The numbers don't have to be different. Did you hear that? I can have the number 8 in there 5 times, and it's not. We could change that if we wanted to. I didn't. I tried to keep this simple. So if we put in a 1, we're going to get a new array with 25 random numbers, each number between 1 and 100. Does that make sense? All right. If we type in a 1, we're going to display that array. So anytime we want to display it, but notice the key thing, in its original order. We're going to manipulate the array, but we're going to keep its original order. How are we going to do that? We're going to make a copy of it. So we'll have the original and a copy. All right? All right. Then, if we type in a 3, we want those 25 numbers to appear in ascending order, 1 to 100. We type in a 4, we want it to be in descending order, 100 to 1. All right? Now think about this. This should make sense to you. That if we put it into ascending order from 1 to 100, whatever the first element is now the smallest element in the array. Does that make sense? If we put it in descending order from 100 to 1, then the first element is the largest element in the array. Does that make sense? All right. Then we'll give the user the ability to add all of the elements together. When you add them together, think about this. We've got 25 elements. Each element is between 1 and 100. All right? So if it actually gives us a true random, each number should be about 50. On average. I might have a 1, but then a 99. Do you understand what I'm saying? So if I do a 25 times 50, when I do add them up, it should be somewhere around 1,250. Not there, but somewhere around there. Then when I take that number and I divide that by 25, it'll give me the average. So does all that make sense? Because this is what we're going to do. We're going to start it now. Like I said, when it's 5:02, it's 8:46. So in 9 minutes, we're taking a break regardless of where we are. All right? I've got my cheat sheet because I've done the program already. So I put a bunch of stuff in here. Kind of, again, trying to really emphasize the stuff we've been working with. All right. This is going to be the size of our array. There's going to be 25 elements in it, so I made a constant called size. Now remember, with JavaScript, even if I say that it's 25, I can still make it bigger because JavaScript allows you to change the size of arrays as programs are running. JavaScript and PHP are the only two of the probably 12 programming languages I know that allow you to change the size of an array while the program's running. All right? This will be the same array. That's the original copy of the array. So when I put in a number 2 there that says, show me the numbers in original order, this is what's going to print out. Does that make sense? That's my original 25 numbers in random order. This is the copy of that I'm going to manipulate. So I can put it in ascending, I can put it in descending, or whatever. So these are the same 2 arrays, but numbers original will be in its original order. Numbers copy will allow me to manipulate numbers original. Again, does that make sense? All right. This will be the choice that I make. What the hell is the choice? That'll be the 0, the 1, the 2, the 3, the 4, the 5, the 6, the 7, or the 8. Does that make sense? All right. I'm going to guarantee that it is one of those. All right. This is my minimum. That's my smallest number. And I made it 101. By making it 101, since my whole gauge is from 1 to 100, I know whatever number I read in there first will become the new minimum. Does that make sense? Max, I set to -1. My numbers go from 1 to 100. I could have made it 0. But I know now the first number that I put in will now become both the min and the max. Does that make sense to everybody? Then I want to check every number against that first one. If it's smaller, it's a new min. If it's greater, it's a new max. All right? This will be the sum of all 25 numbers. When I take that sum and divide it by 25, that'll be the average. Any questions on any of that stuff? All right. Now, this I don't know if you've ever heard of this word before. Still haven't. Anybody ever hear this term before? All right. A kludge. As far as in IT terms, do you ever hear the old saying, you can't put a square peg in a round hole? You ever heard that? Well, you can if you've got a big enough hammer and you hit it hard enough, right? I mean, you might splinter it, but you can put it in there. Much the same way, my dad used to always say, you can't use a screwdriver to pound in a nail. Well, give me a big enough screwdriver and let me hit it hard enough and I might be able to. With a kludge, you make something work. It's not an ideal way of doing it, but you shoehorn it in, for lack of better words, to make it work. Well, why am I telling you that? Because I had to do this. Originally, I set this up So the only thing that was in this particular function, only thing, there was no while loop. All it said was this. In fact, I'm sorry. In the while loop here, I'm going to remove this right now. And I'm going to, so let me do a control X. What was in here originally was this, which meant forever show that menu. Do it forever. While 1 equal 1, well, 1 better always equal 1, correct? So while that happens, call show menu. The problem was I tried to come in here and tell it that when I call the 1, I kept saying, how do you return from a JavaScript, how do you end a JavaScript program? There are languages like Java that allow you to say system.exit, that's a little e, sorry, system.exit 0, which means wherever you are in the program, kill it. JavaScript doesn't have anything like that. So even though I put in there return, it returned, but it's still, that 0 didn't work. Do you understand what I'm saying? So I said 0 will end the program. It didn't. So I had to change that to say this. To say whatever I selected, whatever that show menu gives me, 1, 2, whatever, whatever it is, return it to here. And if it's a 0, stop the program. Does that make sense? That was the only way I could figure out to do it. Is there another way? I went online and I was out on all sorts of different sites. All right, and listen, and had people saying, "Oh, do it this way," and another person would come in there and say, "That makes absolutely no sense." And just listening to these arguments, electronic arguments, I figured this was the cheesy way, but it's a kludge, but it works. All right. So this right here, this selection. In fact, it shouldn't say selection. It should say choice. I don't know if yours says selection. Make sure it says choice. Okay. All right. So choice equals show menu. If that choice happened to be 0, return. You're done. That's it. All right. So this, do I have to go over, I'm asking you, do I have to go over this with you? Do you understand that that right there built that alert box that you saw that said enter a 0 to end the program, enter a 1, etc.? Does that make sense to everyone? Yes? No? Anybody it does not make sense to? And I'm putting it all into a variable called output str, which is output string, and I just keep adding to it. Then I say choice equals, and that choice that's right there, that choice, that's this choice. Okay? It's going to be a parse int of whatever I put in. If I put in something that's non-numeric, or a number less than 0, or a number greater than 8, I just tell you to do it again. This is new. Some of you are shaking your head. Yeah, I get it. You've never seen this before. What do I mean? What am I calling here? What is that? What's that a call to? What is that? What does that say? Show menu. What function am I in when I'm calling it? Show menu. That's what's known as a recursive function call. That's a function that calls itself. So this says that while I put in something that's out of range, just call the function all over again. Why did I do it like that? I didn't have to. Do I really want to go and repeat this same stuff? Again, I didn't want to do that. There's other ways this could have been done. But this is the way I did it. All right? So ideally, at least, all right, ideally, when I get down to here, I put in a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, or an 8. Does all that make sense? Questions? No? All right, then let's take a break and we'll start going over the call correct method after the break. I've got 8:54. Let's come back, please, at 9:05. Yes?
That changing selection to choice, the program no longer works.
Is that right? Well, not sure then. What did I do down here?
That doesn't make sense.
I'll have to check in here. All right then, don't make it that. Make it selection.
Selection is also not defined
No, it doesn't. But as long as it works, we're just gonna work with it right now. All right.